Chapter 13 review. Let's see if I can do these without messing anything up. So I'm on page 234. And for number 1, when a die is rolled, each of the 6 faces is equally likely to come up, which means the dice is fair. It's a fair dice. Everything's equally likely. A deck of cards has 4 suits and 13 cards in each suit, and then we'll be referring to this. So number 1, true or false? A, if something has a probability of 1,000%, it is sure to happen. False. You can't go over 100%. Are you on your phone? Oh, that hurt your grade. That's true. So, letter B, if something has probability 90%, it is expected to happen about 9 times as often as its opposite. So if it's expected to happen 9 out of 10, it's expected not to happen 1 out of 10. So the expectation of winning is 9 times higher than the expectation of losing. So that would be true. Number 2, 2 cards will be dealt off the top of a well-shuffled deck. You have a choice. 1, to win $1 if the first is a king, and 2, to win $1 if the first is a king and the second is a queen. Which option is better? The first one. What's the probability of the first one happening? 1 out of, so 4 out of 52 or 1 out of 13. Darian, you're on your phone too. You guys are making me sad. Oh, good. And the probability of the next one is 1 out of 13 times 4 out of 51, which is going to be a much, much smaller. 3, 4 cards will be dealt off the top of a well-shuffled deck. There are 2 options. To win $1 if the first card is a club and the second card is a diamond, and the third is a heart and the fourth is a spade, or to win $1 if the 4 cards are of 4 different suits. Which one's better? The second one. Right. The first one has to be in a specific order. So that's number 3. So if the first card is a heart, then you lose number 1. Right? You're out. But for the second one, it's okay as long as none of the others are a heart. You might be all right. So the second option is much better. And I'm not very good at calculating probabilities, so I probably couldn't figure out what the probability of that first one is. I could calculate the second one. The second one's easy. It's just, it would just be, it would have 2 combinations in there, but it wouldn't be hard. Number 4, a poker hand is dealt. Find the chance that the first 4 cards are aces and the 5th is a king. So, what is the chance that the first card is an ace? 4 out of 52. Okay. What is the chance that the second card is an ace? 3 out of 51. And the third? Whoa, not 31 out of 51. So 2 out of 50. And the next one? 1 out of 49. And then the last one? There are 4 kings out of 48 cards. So you're going to get a very, very small number. Okay. All right. Number 4. Nope, number 5. 1 ticket will be drawn at random from the box below. Are color and number independent? So I have 3 whites, 3 blacks, 2 1s in the white, 1 8 in the white, 2 1s in the black, 1 8 in the black. Are they dependent or independent? How do we check to see if they're dependent? So, what's the probability of drawing a 1? 4 out of 6. But what is the probability of drawing a 1 if you know you have a white? 2 out of 3, which is equal to 4 out of 6. So that one works. Does the same happen with the 8s? And let's try it the other way. What's the chance of drawing a white? 3 out of 6. What's the chance of drawing a white if you know you have an 8? 1 out of 2, which is the same as 3 out of 6. So color and number are independent. And one way you can look at it is there are just as many 1s inside the white as there are inside the black. And there are just as many 8s inside the white as there are inside the black. So you really don't even need to do the probabilities. You can just look at it and make sure everything's symmetric. And then you know that they're independent. Number 6, a deck of cards is shuffled and the top 2 cards are placed face down on a table. True or false, and explain. There is a 1 chance in 52 for the first card to be an ace of clubs. True. There is a 1 in 52 chance for the second card to be the ace of diamonds. Oh, that's a tough one. We don't know what it is, but it is something, right? It's something. So my guess would be,
Is there a replacement or not?
It says the 2 cards are placed face down on the table.
so there was an order, right? So my guess, and we don't have answers to review exercises, right? Right. We don't know what it is, but it does exist. And I think in one of the exercises, wasn't there a question like this? And it said false. So I think it's false. I'm going to try not to ask you a question like that. That's really cruel. I mean, let's stick to the stuff that makes sense to us. And it's kind of like asking, let's say I flip a coin and I hide it, and I ask you, what's the probability that the coin is head? You would say 50%, but you'd be wrong because it's either head or it's tails. So the probability is either 0 or 1. Just because you don't know doesn't mean that it's, it has already happened. So if you ask the question, if I flip this coin, what's the probability of it being heads? Then it would be 50. But if the event has already happened, then it's either yes or no. Yeah, did we not? Oh, yeah, then I'll do one today. Yeah. Well, a lot of times I pick before these days. Okay, so I'm not going to be terribly picky on that, but do you see what I mean? If I flip a coin and I'm looking at it and it has already happened, it's not a 50% chance. If you guess, you have a 50% chance of being right. But the coin is either H or T, and you can't change that. So it's either 0 or 1. So I think the same thing applies in this case. That first card is either the one you're looking for or it's not. But it does exist, so I would say false. Yeah, and then in C, what's wrong with C? The second one should be 1 out of 51. Okay? And I don't think this is going to be terribly important on tests or final. I mean, that's kind of picky, and I can't imagine they're going to ask that sort of question. Okay, a coin is tossed 6 times. 2 possible sequences of results are that one and the other one. The coin must land H or T. Which of the following is correct and explain? Sequence 1 is more likely. What's the chance that sequence 1 happens? No, so what's the chance that you flip it 6 times and you get H, T, T, H, T, H? 1 out of however many options there are, right? What's the chance that you get H, 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 H? 1 out of that same number. So the first one is this likely? 1 out of the total, and the second one is also 1 out of the total. Now, before you took this class, and I would have asked you which one would you pick, everybody would have picked 1, right? But this matters because there is an order, right? There's a first coin and a second coin and a third coin and a fourth coin. If I said we're going to flip coins and you get to choose between picking every coin was an H or 3 half H's and half T's, then you would pick the second one because there's no order. But if you put them in order, H, T, T, H, T, H is just as likely as all H's or any other permutation that you could think of. All T's or TH, TH, TH or H, TH, TH, T. Each one of those is equally likely.
So, like, say, like, you demonstrate this and you, have, and write them down, you flip them and then, it happens. Is that why people say, well, you'll never see this again, that was
Yeah, as long as there's an order. If there's not an order, then this changes. Okay, the chances of getting all H's is far less likely than a combination of H's and T's. Right. Yep. How likely are you to get 3 T's and 3 H's? Very likely. Most of them will probably have 3, well, not most, but more than any other combination will be 3 H's and 3 T's. But as soon as you put them in order, that changes things. All right, 8. A die is rolled 4 times. What is the chance that all of the rolls show 3 or more spots? So on the first roll, what's the chance that you get a 3 or higher? 4 out of 6, right? Because you have a 3, 4, 5, and 6. So the first roll has a 4 out of 6. Is the second roll independent or dependent of the first? Independent, so do I change the denominator? No. The second roll will have 4 out of 6, 4 out of 6, and 4 out of 6. We're doing it 4 times, right? Okay, and I'm going to simplify all these. It's going to be 2 over 3 to the 4th, which is 16 over 81. So 16 out of 81 times, you will get dice that have 3s or more on all 4 dice. Okay. None of the rolls show up 3 or more spots. Well, the easy way to do this would just be, can we just do 81 minus 16? No, because inside there you have some, right? This has all over 80 or all over 3 or over. So we can't do the easy way and do 81 minus 16 because, so what would that be? 81 minus 16 is going to be 65. What does that 65 tell us? 65 times you have fewer than 4 that are 3 and up. Yeah, so we want to do 1 and 2. So it'd be 2 over 6 times 2 over 6 times 2 over 6 times 2 over 6. It would be 1 over 3 to the 4th, which is just, or sorry, not, yeah. So 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3. So that's 1 out of 81. Yeah. So you have a 1 out of 81 chance. So if you roll the dice 4 times, it's 2 over 6, which simplifies to 1 over 3. And then you raise that to the 4th, you get 1 over 81. So if you were to do this 81 times, you would expect 1 time to have numbers that are 1 or 2. Okay? Not all the rolls show 3 or more spots. That's going to be the 65. Right? Because 16 out of 81 times, every single dice is 3 or more. So we just need one of those not to work, or all of them, right? If one of the rolls has a dice less than 3, then we win. Well, that would be 81 minus 16 over 81. So it'd be 65 out of 81. So we found the chance of getting 3s or more on all dice, and we just want to know what's the chance of that not happening. It would be 81 minus 16 over 81. Okay. 9. A die is rolled 10 times. Find the chance of getting 10 sixes. So what's the chance of getting a 6 on the first roll? 1 out of 6. For all of them, so we have 1 out of 6, and we're going to perform that 10 times. That's a really small number. So 1 divided by 6 to the 10th is 0.00000000165. Yep. That's the decimal. The percentage would look a little bit better, but yeah, not very likely. If you roll 10 dice, what's the chances of getting a 10 number Yahtzee? It's pretty impossible. Not going to happen very often. If you try to turn that into a fraction, the calculator won't do it. It's just the denominator's too big. Okay. Not getting 10 sixes. It would be 1 minus this. Right? So 1 minus the answer, it's probably just going to give me, oh, look at that, 0.99999999835. Jeff, wake up. Guaranteed. Yeah. So what's the chance of getting all 6s? Very tiny. What's the chances that your roll does not have all 6s? Extremely likely, because those two added together should be 100%. All right. And all rolls showing 5 spots or less. What's the chance of getting 5 spots on the first dice? 5 out of 6. And the next one? 5 out of 6. We want to eliminate the chance of ever getting a 6. So we're going to do 5 out of 6 times 5 out of 6. And we're going to do that 10 times. So 5 to the 10th over 6 to the 10th will be our answer. %. Why is that so small? If you roll 10 dice, would you expect to get a 6? How many 6s? 1 or 2, right? 1.5. We would expect to get 1.5 6s. So the chances of never getting a 6 has to be pretty small, because we would expect a 6, at least 1, maybe 2 in 10 rolls. Okay. Which of the two options is better, or are they the same? 1, you toss a coin 100 times. On each toss, if the coin lands head, you win $1. If it lands tails, you lose $1. Then number 2, you draw 100 times at random with replacement from a box of 0, 1. On each draw, you are paid in dollars the number on the ticket. Which one would you rather have? The second one. How come? You never lose. Okay, if you played the first game, how much is the casino expected to win? If you played 100 times, what's the profit of the casino? The profit. So you pay $1 every time. Well, I guess no, you either pay or receive. But how much of an advantage does the casino have in the first game? None. None whatsoever. And I found a game in Las Vegas that was at the New York, and as far as I could tell, it was the only game worth playing ever. And I think it had 5 dice in this cage, and they spun the cage, and then when the dice landed, you added up the dice, and you could bet lots of things. What's the chance of all of the dice adding to be 10 or 11 or all the dice being odd? And that's not worth it. But there was one line you could bet, and it said, if the sum of the dice is 15 or lower, then you win. If the sum of the dice is 15 or higher, or 16 or higher, then you win. And you could bet either one. And there's a 50-50 chance of winning, right? Because half of 30 is 15. And the payout was 2 to 1. For every dollar you pay, if you win, you get paid $2. Now, if you can find a game like that, that's the only game worth winning. And here's what you do. So if you have a 50-50 chance of winning and the payout is 2 to 1, then you bet $1. Okay? If you win, you keep your dollar. Nope, you just keep betting $1. Okay? If you lose, you have now spent $1. So the next time you win, you want to make that dollar back. So you're going to bet $2. Okay? So you bet $2 and you win. And you win $4. So you now you've spent 3 and you've been paid 4, so you won $1. Right? Okay, so let's say you bet $1 and you lose, and you bet again $2 and you lose, and you bet again, you're going to bet $4. Okay? You'll bet $4. So how much have I spent? 7. And let's say I win, I get 8 and I won $1. Okay? So let's play again. We bet $1 and we lose. And you bet $2 and you lose. And you bet $4 and you lose. So now you bet $8. How much money have I spent on this round? 15. I've spent 15, but if I win, I get paid $16, and for this round, I won $1. And I play the next time and I win $1. The next time I bet $1. Every time you win, you bet $1. Every time you lose, you bet twice as much as you played last time. And then for every set of loses, you will win $1. Now, you have to make sure you have enough cash, because if you lose 16 times in a row, you're going to have to dish out a lot of money. So you got to make sure you have enough cash, because if you run out of money, then you've just lost a whole bunch of money, because this gets big pretty quickly. So it would be 16, 32, 64, 128, 256, 512. So if you can find a game like this and you have enough money, you are guaranteed to never lose. You'll only win $1 at a time. Would you want to start with $5? No. Why? You'd have to go 5, then 10, and then 20, and then 40. So it's much safer with $1. And as far as I could tell, that's how this game worked. Well, but what I'm saying, it's the only game in Vegas where the casino does not have an advantage. That's true, but you could gamble and not lose. If you play the other games, you're going to lose. Can we do the same thing with roulette? So I bet on black. I bet $1 on black, and I lose. So I bet $2 and I win, and now I've spent 3 and earned 4, so I'm $1 ahead. And then I start over. Bet $1, I win. Bet $1 on red and I win. Bet $1 on red and I lose. So then I bet $2 and I lose, and I bet $4. Why will that not work with roulette? Nope, they don't. Why will roulette not work, but this game will? It's not 50-50. Why not? The 2 green squares wreck it. So a roulette wheel has, I think it has 16 reds, no, 15 reds and 15 blacks and 2 greens or something like that. What's that? The greens are to prevent you from doing this. They're 0 and double 0, I think. So I think there's 1 through 30 or 1 through 32, and the odds are red and the evens are black or something like that, and then 2 greens. And you can bet just the greens, right? You have like a 1 in 16 chance of hitting a green, but they're not going to pay you $16. They're going to pay you 14, and they keep the other 2. So if you can find a game like this and you have enough money, you're guaranteed to never lose. Yeah, it's not worth it. Don't do it. Well, yeah, but you always run the chance of a long string of losses. So in this game, if you string together a bunch of losses, which statistically can happen, then you just lost a lot of money. Okay, so 11. In the box shown, each ticket should have 2 numbers. A ticket will be drawn at random. Can you fill in the blanks so the numbers are independent? Well, how many start with a 1? 4. How many start with a 3? 4. Okay. So how many of the 1s end in a 2? 2. How many of the 3s end in a 2? 1. So I have to have another 2 with the 3s, right? So one of the blank spaces after a 3 is a 2. What's the other one? So let me take a picture of this so make sure everybody's on the same page. All right. So I know that one of these must be a 2. Now I have 2 that end in 2 and 2 that end in 2. Okay? I have a 1 that ends in a 3. Do I have a 3 that ends in a 3? No. So that has to be a 3. And then I have a 3 that ends in a 2, which means I need a 1 that ends in a 2. Oh, that's not what I wanted. This is the one I was looking at. We have a 3 that ends in a 1, so that has to be a 1, and now it's independent. So I have a 3 that ends in a 1. In order to be independent, I have to have a 1 that ends in a 1. All right? Number 12. You're thinking about playing a lottery. Bad idea. Lottery is a tax on stupid people. Do you know why states implement lotteries? To make money. So half of the money that is paid in lottery tickets goes out to the prize winners. And then the other half the state keeps and uses for whatever it wants to. And then if you win the lottery, they say, we'll give you $300 million over 20 years. And you say, I don't want to wait that long. They said, okay, we'll give you half of it over 10 years. And you say, I don't want to wait that long. I want it all right now. Okay, we'll give you 1/10 of your money. We'll just write you a check right now. Yeah, bad idea. Okay, the rules. You buy a ticket, choose 3 different numbers from 1 to 100 and write them on a ticket. The lottery has a box with 100 balls numbered 1 through 100. 3 balls are drawn at random without replacement. If the numbers on the balls are the same as the numbers on your ticket, you win. If you decide to play, what is your chance of winning? So would we do 1 over 100 times 1 over 99 times 1 over 98? No. Because we did without replacement, and order doesn't matter. If you write 2, 4, 6, and the balls come out 6, 4, 2, do you still win? Yes. So order doesn't matter. So this is actually a combination, and I don't think we're going to get too far in depth to this. It would be 3C100. That's how you'd calculate it. So 3 math. We go over to probability. 3C100. Oh, it's 100C3. Sorry. 100, choose 3. So it's 16,100 and 1,700. Wait, no. 161,700.
So it's 1 out of
One. Yeah. Yep. All right. That's it.